Hello, this is video D, and I erased C++ syntax as the title because you know what? Until further notice, it's all C++ syntax, and that's redundant and it was taking up space. So we're in the know now. We know all this is just C++ syntax, and I might have accidentally lied last time. I think I might have said, you know what? We're going to start next time with things that actually do something. Not quite. We've still got to do a little more setup in the name, for example, of variable definition, variable definition. If you've been sitting around rolling your eyes saying, when are we going to do something new? Well, if you're coming from Python, this is something new because Python infers variable data types and sets up memory boxes on the fly. In C++, you've got to be much more specific and much more deliberate, and I'll show you what I'm talking about. Right here. Format. You have to define a variable before you can use it. You have to not only say what the name of the variable is, you have to say what kind of thing is going to go in it. So the format looks like this. Out front, using my pointy brackets convention again, type, space, at least one space, then pointy bracket, variable list, close pointy brackets, and a big fat semicolon. It's one of those statements that has to have a semicolon at the end of it. The effect of this defines, D-E-F-I-N-E-S, each identifier, there's our word again, I-D-E-N-T-I-F-I-E-R, and variable list, defines each identifier in variable list to be a new variable of type, pointy bracket type. Now, that might have so many symbols. Using my pointy bracket convention, it doesn't make any sense. Let me fill in the blank. Let's say that variable list is A, comma, B, comma, C. I already regret that. Don't use single letters for variable name. Let's say variable list is apple, comma, banana, comma, cantaloupe. There you go. Defines each identifier in apple, comma, banana, comma, cantaloupe to be a new variable of type, and then fill in the blank here, int. We know the int data type. So that would have defined three new variables that I could use in my program if I want to. Apple and banana and cantaloupe are each variables that could hold an integer. How exciting. To get a little more technical about it and to refer back to earlier pictures, technically what it's doing behind the scenes is associating each one of the identifiers in the variable list with a specific memory location inside our program. When our program is turned into a core image and loaded into memory so it can run, all of those instructions that we told it to do, that we'll get to later, all those instructions in zeros and ones, those are all loaded in there, but also loaded in there are these chunks of memory that correspond to all of the variables, so that we have places to put the results of our calculations and places to put the number that we ask the user to type in, all that stuff. Each one of those is like a little brick in memory that's associated with some variable name in our program so that we can put stuff in there. Now I'm repeating myself. Let's not do that anymore. Here are some examples. I'll put these up here and then talk about them. Int, space, days, comma, weeks. That's enough, semicolon. And yes, I can do more than one variable. I can do exactly one variable. Let's do exactly one variable. Double, D-O-U-B-L-E, which we've never seen before, but look, from the position I can infer or figure out from this format that must be a data type. In fact, it is. Double GPA. And if that's the only double variable I need in my program, I'll just put a semicolon after that. Yet another variable definition. How about this one? Char. Letter, comma, digit, comma, and here comes my camel casing again, Letter, capital G for grade. Letter grade. There we go. And I'm going to knock a couple of others out while we're at it. String. And we've already seen at least one example so far where string, we know that's not a kite string. Name, comma, address, semicolon. One more. Bool. B-O-O-L. Space. Is ready. Camel cased. Yeah. Tiny whiteboard. There's no room to write out descriptions of all these. So please listen. Int is the data type out front. That says that days, the way I would represent this, days, is a variable, and that is an open box that says that maybe days, I could set that to 3, for example. I'd put a 3 there. The reason it's called a variable is there are ways to change it. Maybe I read in a different number of days from the keyboard after I tell the user to type it in. And they type in 9. So the value would change to 9, for example. A variable in use. But in C++, it has to be defined. It has to be set up before you could use it. It's not nice like Python and just go ahead and give you any variable you want to use. The compiler has to see that variable before it will let you use it in a statement. Same thing for weeks here. So there's 2 integer variables. Double, I bet you've already figured that out by the variable I used here, GPA. Normally, you want something that's a less blunt tool than a whole number for your GPA. It'd be great if you had a 4.0, but maybe you don't. If you have a 3.85, you probably don't want that rounded to 3, or truncated, not rounded, but truncated to 3. So GPA, double just means double precision. I don't know why they use that word, but hey, I wasn't around when they designed C++. Double means it's a number that can have a decimal point, positive or negative. It's represented completely different from the integer variables inside memory. It's all still a bunch of zeros and ones, but it's got all these different pieces to it. It's got the positive or negative sign. It's got the exponent on powers of 2 and all these other weird things. That's all behind the scenes for us. Char. We've met char before, haven't we? Char is a single character keystroke. Char. So character, a single letter. I can store a single character in a single letter. A digit. It would make sense for me to only put something 0 through 9 in there, but the data type would allow me to put a question mark in there, or a plus sign, or a space, something like that. Letter grade, camel case, A, B, C, D, F, whatever it may be. But each one of those makes sense as a single character, therefore I could use char. A more general one, and by more general I mean we're not limited to just one char. I could have a single character name. My name could be A. Hey, how's it going today? My name could be A, my name could be F, my name could be Z, whatever. But it doesn't have to be if it's a string. Maybe my real name is Alfred. That's what my mom calls me. So I could store all of the string Alfred in string variable name. The address, I could store my address in there, 123 Leestown Road, whatever it may be. I can even put spaces in there. Anything that can be represented as a string can be stored as a string variable. Here's perhaps a mysterious one. Bool. Bool is short for Boolean. There, mystery solved. No, this means that the only values that make sense for this variable are true and false. Applications start popping in mind. Flags, for example. Did something happen or did it not happen? True or false? Was that file open when I tried to open it or did it not? And I want to avoid crashing my program. These are strangely useful. And by strangely, I mean, it might seem like, if it can only have 2 values, it's not going to be very useful. But they turn out to be ridiculously useful, as we will find out later. A convention, here comes another convention. It's already conventionally camel cased with a capital R. A convention for Boolean variables is to put things like is together with other words. Is ready, if I'm working with files, is open. It really indicates, that variable name indicates that this is going to tell me true or false, a yes or no answer. Is that ready? Is it not ready? Or whatever, and I can test it later on when I know about if statements and know how to use for loops and so forth. I can use this as if that too. As if it is an entire condition in its own right. without even having to use any conditional operators. There. That is all about variable definitions, and I'll lie to you no longer. Let's get busy and have some statements that actually do something. I think we can manage that now. These are called assignment statements. Abbreviated STMTS. Takes up less space, takes up less time. The format. What do assignment statements look like? Well, abstractly represented, on the left, they have to have a single variable, V-A-R-I-A-B-L-E. No variable list separated by commas, no pair of variables separated by spaces, no strings inside double quotation marks, nothing like that. Just a single variable and nothing else. A single equal sign, and on the right-hand side, an expression, E-X-P-R-E-S-S-I-O-N, semicolon. Now, this is arguably the most important statement in C++ syntax we've looked at so far, because it does actually do something, for crying out loud. What does it do? Well, I'm going to annotate this and then talk about what it does. I'm going to start on the right-hand side. We're going to go backwards, like we're reading Arabic or something. This is going to be part 1. After part 1, then we take a look at part 2. And I'll even use the different colors in my effect here. Part 1. What happens when we hit this assignment statement? The computer, we know it's the CPU, the thinking part of the computer, but I'll pretend like we're not that smart. Computer evaluates pointing brackets expression. E-X-P-R-E-S-S-I-O-N, comma, which then, W-H-I-C-H, then becomes, wait for it, ... 2. The new value of variable. There is actually an activity. This is not just set up, this is actually doing something. The CPU is called upon when we get to this statement to evaluate the expression 2 plus 2. Can you do that, CPU? CPU says, yeah, 2 plus 2 is 4. That's phase 1. Now the 4 is copied into variable on the left-hand side, making that the new value of variable. Well, what if it was already 4? Doesn't matter. Puts a new 4 in there. It copies a brand new 4 on top of the old 4. What if it was a 19? That doesn't matter either. Now here's where we've got to be careful. Variables have no mechanism to remember their old values. In other words, if this started off at 19, when we got to the statement that said variable equals 2 plus 2, then that 19 is not long for this world. It's about to be gone forever. Because when this does 2 plus 2 on the right-hand side and puts it over a variable, I'm going to stop talking like this. When it puts the 2 plus 2 result, the 4 over here on top of the 19, poof, the 19's bit pattern is abolished. That's not a good word. I don't think it's a word at all. It's obliterated. It's gone. And it's irretrievable. Now all the big words come to me. Okay, that's the effect. How about some examples? Examples. Int. Now this is not an example of assignment. I've got to set it up. Here we go. Int blue, comma, red. Semicolon. Red equals 10. Semicolon. Blue equals red plus 2. I'm making this up as I go along. We ask that you bear with us. Red equals red plus 700. semicolon. And more might come to me. You know what? I'm going to do one more. Blue equals red plus 2. And now I'm just getting silly. I've already done that. Yada, yada, yada. Here is an essential skill for you. You have got to be able to trace code, which means you get inside the mind of the computer and figure out exactly what the computer is going to do when it sees this sequence of statements. Let's do that, shall we? When it hits this statement, we know what that does. It sets up brand new variables. I hope you can read this. Let me get the darker green. That might work better. 2 brand new variables, blue and red. And that's an optical illusion. Your minds are deceiving you. It looks like, based on this line alone, it looks like blue and red don't have anything in them. There's always going to be something there. If we don't put something explicit in there, be careful about this. If we don't put something explicit in there, it is a random bit pattern. Depending on your machine, it's a random sequence of zeros and ones of length 32 bits, or maybe 64 bits. Garbage or big garbage, your choice. I represent garbage with a question mark, which is a visual reminder to me, don't try to use the value of this variable until I've put something in there. I'll come back and hit that again in a second. But here, to make the trace complete and less error prone, whenever you set up new variables in C++, initialize them to garbage, unless they're initialized to something else. I could have put values here for these, but this is kind of a standard convention. Set up your variables first and then use them. Then away we go. All the rest of these are assignment statements, and it's always going to be 1, 2, starting on the right, then left. The right-hand side, I think I can evaluate that. 10 is 10, yeah, okay. So the value of that expression is 10, and it becomes a new value of variable red over here on the left. Red is no longer garbage, it is now 10. Look at this. Blue equals red plus 2. Now, even though I read it that way, that is not how it operates. The computer, believe it or not, doesn't care, doesn't even look and see what's on the left-hand side of the equals until it finishes its business on the right-hand side. The right-hand side said add red plus 2. Red is 10. 10 plus 2 is 12. Even I can do that math. Now that it's got the 12 all figured out, now it looks to see where it should go. It becomes a new value of blue, wiping out the pre-existing garbage. Now, I did this on purpose to show you this ain't no math class. There is no value of variable red that would make this a true equation. This is not an equation. This is an activity. This is the thing that says do what's on the right, then make it happen on the left. There is no number, not even 3. 3 plus 700 is 703. That's not equal to 3. Do you see what I'm saying? That's not an equation. This is it's not a statement of fact. It's a verb. Do what's on the right-hand side. Well, to be able to do that, it's got to look up the current value of variable red. Current value of variable red is 10. 10 plus 700 is 710. Now that it's got that all calculated, it's evaluated the expression. It puts that over here on the left-hand side. So we've got now, instead of 10, 710. Oh, your eyes, you guys need to get glasses. They're deceiving you again. I can see the history of variable red. It was once garbage, then it became a fledgling young 10, and now it's 710. You know more than the computer knows. The computer has no clue what the value of red ever was. All it knows is, right now, it has a 710, and that's it. There's no trace. There's no history. One more statement. Now, this statement, look at this. Blue equals red plus 2. We're doing it again. Blue equals red plus 2. You might think, well, it's got to be exactly the same, isn't it? It's the same statement. Tis not. Tis not. Because of the sequence. This is my passive-aggressive way of leading you into, ideally, understanding that the order that these statements happen makes a big difference. That's why I made a big deal about a program being a sequence of statements. This statement, because of its different location, does something different because the value of red is very different from what it was before. The current value of red when we get here is 710. 710 plus 2 is 712. Man, I'm like a human calculator. Did you see how quick I did that? 710 plus 2, 712. That becomes the new value of blue. So this is now 712 if I did the math correctly. You know what? That's going to be so embarrassing if I did that wrong. Red is 710. 710 plus 2, 712. Blue is now 712. Why did it behave differently this time? Up here it made it a 12. Now it made it a 712. Because of the different order of the statements. Now, of course, some statements, this one doesn't involve blue at all. Let me pause for a second, and this is a place to mark if you have questions about this, because I'm about to butcher this. Let's say, for purposes of argument and hypothesis and all those other good things, let's say that Dr. Earl, you've got some good ideas, but you're just so off track on some things. I want to put these in decreasing order of length, maybe, or something similar to that. And red equals 10, that's a short statement. I'll wait and do that later. So I'll put red equals 10 down here. They're the same statements. There. That's more visually appealing, isn't it? Kind of, sort of. They get shorter and shorter and shorter. Yeah, I like that a lot better. So away we go. We being the computer, seeing things the way the computer sees things. We've got these two variables. I jumped the gun on that a little bit, but we've got two variables, blue and red, both garbage. And here we go. Blue equals red plus 2. Now, a C++ compiler that is your friend will yell at you and refuse to translate your program into machine language. Let's be a bad compiler. Ooh, old school compiler. Maybe they don't care. They're not going to tell you. You have to actually put a value in variable red before you could use it. So it looks up the value of variable red, which is garbage. Garbage plus 2. Let me see. I could do that. That's too big or garbage. So what this is doing is dumping more garbage in blue, replacing the old garbage that was there, and you see what the problem is. Garbage in, garbage out. Too large or garbage, that's still garbage. This is not good. This is not good. A rule of thumb, before a variable shows up on the right-hand side of an assignment statement, it darn well better show up on the left. That's what was broken when I moved this statement down here. Before red shows up on the right, it better show up on the left. Showing up on the left means it does have some deterministic, in other words, some value that I can figure out using the rules of C++. I can figure out the value of variable red if I assign it to be 10. If it's garbage over here, like I said, a more modern compiler that actually is your friend is going to refuse and give you probably a blood red error message that says undefined value for variable red, something like that. It actually tries to help you, keep you, it saves you from hurting yourself in your program. So be careful, don't let that happen to you. Wow, the next sheet has a bunch of stuff on it. You know what? Assignment statements, that's a pretty big deal. If all this soaks in, then that's job well done, and I'm going to call it quits here and say, I'll see you online.